Hello everyone, my name is Caitlin Hessenthaler. I am a graduate student at Eastern Illinois University, and I am a part of the MSND program with a dietetic internship option, and this is my systematic review presentation. So just a quick overview of my presentation today. First, I will introduce the topic, then I will give a brief background, followed by my purpose statement and research question, the literature review, and then ending with a discussion. Vitamin D has been recognized for its involvement in skeletal and calcium metabolism and is now suspected to influence non-skeletal targets, including brain health and function. The biologic mechanisms linking vitamin D to the brain have been extensively studied, but it is not yet fully clear. Vitamin D has a crucial role in proliferation, differentiation, neurotrophism, neuroprotection, neurotransmission, and neuroplasticity of cells. It exerts its biologic function not only by influencing cellular processes directly, but also by influencing gene expression. It increases the synthesis of neurotrophic agents such as nerve growth factor and accelerates the growth of hippocampal neurons in a dose-dependent manner. Vitamin D may be involved in neuroprotection by suppressing the expression of inflammatory cytokines, thus promoting neuron viability and function. Vitamin D also decreases the burden of amyloid plaques, which are hard, insoluble accumulations of beta amyloid proteins that clump together between neurons in the brains of Alzheimer's patients. And I'll go into that a little more in depth in a couple of slides. Serum levels of vitamin D are most often tested by assessing circulating levels of 25-hydroxy vitamin D, which for the remainder of the presentation will be shortened to 25-OHD, it's the combined product of skin synthesis from sun exposure as well as dietary sources. 25-hydroxy vitamin D is a pre-hormone that is produced in the liver by hydroxylation of vitamin D3 by the enzyme cholecalciferol 25-hydroxylase. It has a long circulating half-life of 15 days, which is one of the reasons why it's primarily used as an assessment of vitamin D. And unfortunately, there's not currently an official agreement regarding blood levels of 25-hydroxy vitamin D that indicate deficiency, insufficiency, or sufficiency of vitamin D, especially related to brain health. However, most practitioners favor 25-hydroxy vitamin D serum levels of at least 30 nanograms per milliliter. And as a review, the best sources of vitamin D are the exposure of a large amount of skin to sunlight for at least 15 to 20 minutes a day without sunscreen, and foods such as oily fish and egg yolks, and fortified foods such as milks and cereals. The recommended intake of vitamin D, like I said, is not completely agreed upon, but currently 15 micrograms per milliliter or 600 international units is recommended for males and females aged 1 to 70, and 20 micrograms per milliliter or 800 international units for adults older than 70. According to the Endocrine Society, vitamin D deficiency equates to 25-hydroxy vitamin D levels below 20 nanograms per milliliter. Insufficiency is 21 to 29 nanograms per milliliter, and adequate is at or above 30. Some experts say this level is solely based on vitamin D's effect on bone health and not addressing cognitive decline. Vitamin D deficiency has many causes. It can occur in people who cannot get vitamin D, such as those who do not get enough sunlight. Older people are at risk for deficiency because they are not able to make enough of the vitamin in the skin, and it's estimated that 40 to 100% of the elderly populations in Europe and North America are deficient. Those with liver and kidney disease are also at risk because they are not able to process the hormone. Medications such as anti-seizure meds and steroids may inhibit vitamin D absorption, and vitamin D deficiency may run in families. The brain has vitamin D receptors, or VDRs, that help to prevent against and aid in reversal of neurocognitive decline. These receptors are expressed in the prefrontal cortex, the cingulate gyrus, basal forebrain, the thalamus, hypothalamus, cerebellum, among other places. And VDR polymorphisms are associated with cognitive decline. Vitamin D enhances cerebral clearance of human amyloid beta peptide. Vitamin D prevents amyloid beta induced alterations in cortical neurons through upregulation of the VDR. And vitamin D enhances amyloid beta deposition through modulation of amyloid processing. Dementia is an overall term that covers a wide range of specific medical conditions that are caused by abnormal brain changes that trigger a decline in cognitive abilities. These conditions also affect behavior, feelings, and relationships. Dementia is caused by damage to brain cells. This damage interferes with the ability of brain cells to communicate with each other. When there is damage in a distinct region of the brain, the cells in that region can no longer carry out its normal functions. Alzheimer's is the most common cause of dementia and accounts for 60 to 80% of dementia cases. Vascular dementia is the next most common cause and occurs because of microscopic bleeding and blood vessel blockage in the brain. Mild cognitive impairment is a clinical diagnosis representing a doctor's best professional judgment about the reason for a person's symptoms. This can be diagnosed through medical history, assessment of independent function and daily activities, input from a family member or trusted friend, assessment of mental status, neurological examination to assess the function of nerves and reflexes, movement, coordination, balance, and senses, evaluation of mood to detect depression, or lab tests. Current knowledge on dementia pathophysiology indicates that the disease develops over decades of aging. When considering memory mechanisms, it is important to point out that the aging process does not affect long-term memories, but induces a slow and progressive deterioration in the formation and retention of new memories. There's a lack of longitudinal studies researching the effects of vitamin D and cognition, especially in the United States. There's also different definitions of vitamin D status and many different tests for cognitive function, which made inclusion and exclusion criteria difficult and finding studies to fit those criteria. quite hard. And there's also reverse causation as a possibility. The purpose of this is to summarize the current scientific evidence found in a systematic review that assesses the role vitamin D has on cognitive impairment to answer the research question, does adequate vitamin D levels prevent cognitive impairment? So this next session will be the literature review. So first I'll talk about my methods of article retrieval. I met with the research librarian for our subject in the library who showed me how to use the Booth Library database. I used 2 electronic databases to search for articles. These databases were Eric EBSCO and PubMed, and the key terms I used were vitamin D, aging, cognition, memory, and dementia. I read through the article titles and abstracts to identify articles that met my inclusion criteria, and then I performed an independent review of these articles and read the remaining articles and factored in inclusion criteria. I used Mendeley to organize my sources as well as simplify the citation process. So I have 2 different sets of inclusion and exclusion criteria because I have 2 different types of studies that I focused on. One was human studies and one was animal studies. So the inclusion criteria for the human studies is that they had to be peer-reviewed, published between 2009 and 2019. They tested cognitive function with the MMSE or 3MS, which I'll talk about in the next slide. They had to be performed and published in the United States. They had to have a longitudinal study with a follow-up of at least 1 year, and I had to have a free full text. The exclusion criteria was that it's not peer-reviewed, published before 2009, not including the MMSE or 3MS, outside of the United States, and a follow-up is less than 1 year. The inclusion criteria for the animal study is that it's peer-reviewed, published between 2009 and 2019, evaluated cognitive function using a Y maze and or a water maze, which tests working memory. They had to be rodents, and it had to be free full text. The exclusion criteria is not peer-reviewed, published before 2009, non-maze experiments, and non-rodent. The MMSE stands for Mini Mental State Examination. It is a widely used test of cognitive function among the elderly, and it includes tests of orientation, attention, memory, language, and visual spatial skills. It's scored on a 30-point scale, and lower numbers equate to more severe impairment. It was originally used to characterize the severity of cognitive impairment and to monitor the severity over time. It's now used in primary care as part of the initial evaluation of patients with suspected dementia. The 3MS stands for Modified Mini Mental State Examination, which incorporates 4 added test items, more graded scoring, and broadens the scoring range to 0 to 100. The purpose of this is to sample a broader variety of cognitive functions, cover a wider range of difficulty levels, and enhance the reliability and the validity of the scores. A score approximately comparable to that of the original MMSE score can be derived from the administration of the 3MS for more direct comparisons with existing findings. Here's a figure of my article retrieval process. I found 283 articles in the databases Eric EBSCO and PubMed, with the search terms vitamin D, aging, cognition, memory, and dementia. And then I found 10 additional sources through other sources. So I screened the articles and then I found more references within those articles, and that's where this 10 number comes from. There were 94 articles after certain inclusion criteria were applied. That criteria is published between 2009 and 2019, full text and peer-reviewed. And then articles after the duplicates were removed was 89. Then there were 79 full-text articles excluded with reasons, and then that left me with 10 articles used in the systematic review. So some important data that I'll be discussing from the articles is the author, the year published, study design, location of study, evaluation measures, and the results. This first study is called Relationship between 25-hydroxyvitamin D and Cognitive Function in Older Adults, the Health, Aging, and Body Composition Study. Wilson et al. Was the author, and it was published in 2014. It took place in Pittsburgh, Pennsylvania, and Memphis, Tennessee. There was a 4-year follow-up visit, and the evaluation measures used were the 3MS and the digit symbol substitution test, which is a test where participants must transcribe symbols matched to numbers using a legend as fast as possible, and the number of correct symbols within the allowed time is measured, and it assesses processing speed, executive function, and working memory. This study took 2,777 well-functioning adults aged 70 to 79 with a serum 25-hydroxyvitamin D level measured at baseline and at the 12-month follow-up visit, and cognitive function measured at baseline and the 4-year follow-up. 234 participants with cognitive tests at the 4-year follow-up examination were included in the longitudinal analysis. Participants from this analysis were more likely to have lower 25-hydroxyvitamin D levels and lower 3MS and DSST scores. 68% of participants had 25-hydroxyvitamin D levels less than 30, and lower levels associated with lower baseline cognitive scores and greater declines over 4 years. In this analysis, vitamin D deficiency was associated with greater 3MS decline only, with a significance of 0.05. Low hydroxyvitamin D levels were not associated with decline in the digital symbol substitution test scores over time in fully adjusted models. This next study, titled Vitamin D Status and Intakes and Their Association with Cognitive Trajectory, in a longitudinal study of urban adults. It was conducted by Baydon et al. In 2018 in Baltimore, Maryland, and the follow-up time ranged from 1 to 8 years. The evaluation measures used were the MMSE, the California Verbal Learning Test, which measures episodic verbal learning and memory and demonstrates sensitivity to a range of clinical conditions by attempting to link memory deficits with impaired performance on specific tasks. It also used the digital span forward and backwards test, which is used to measure working memory and storage capacity. It used the Benton Visual Retention Test, which measures perception and visual memory. The Animal Fluency Test, where participants produce as many words as possible from a category, in this case it's animals, in a given time, and this test explores semantic memory. A Brief Test of Attention, which is an auditory perception task that measures divided attention in the verbal linguistic system. It used the trail-making tests parts A and B, which is a test of executive function and assesses attention, concentration, psychomotor speed, cognitive shifting, and complex sequencing function by measuring the time required to connect a series of sequentially numbered and lettered circles. Shorter completion time indicates better performance. The last evaluation measure was the clock drawing test, which is exactly what it sounds like. Participants receive a pre-drawn circle and are asked to draw the numbers on the clock, then draw the hands to show a specific time. Participants were both white and black and aged 30 to 64. Participants were either a non-vitamin D containing supplement user at baseline or follow-up, B, a vitamin D containing supplement user at baseline and during follow-up, or C, a vitamin D containing supplement user during follow-up only. They found a consistent relationship between vitamin D status and supplemental intake, with a slower rate of decline in the domain of verbal fluency. In addition, higher dietary intake of vitamin D linked to a slower rate of decline in verbal memory among younger women and a slower rate of decline in visual memory / visio-constructive abilities among white adults. However, all other associations were inconsistent. This next study is the first animal study. It's titled Vitamin D Improves Neurogenesis and Cognition in a Mouse Model of Alzheimer's Disease. The author is Morello et al. And published in 2018, and it used a Y maze. Male transgenic mice were used in this study, overexpressing 2 transgenes bearing 5 mutations linked to the familial Alzheimer's disease, and they were divided into 2 arms. The first was preventative, and the animals were immediately fed from month 1 to 6, and the second arm was curative, and the animals were fed from month 4 to 9 with the same diets. The diets were either a control diet, a vitamin D3 enriched diet, or a totally vitamin D3 depleted diet. Each mouse was eating 15 grams per day, and the enriched vitamin D diet contained a daily dose of 500 international units per kilogram per day. The results indicate that high vitamin D supplementation is efficient in improving working memory, and improved working memory and neurogenesis is observed in high vitamin D supplementation during the early phases of the disease, while a normal dose of vitamin D increased neurogenesis during the late phases. The study, titled Vitamin D Prevents Cognitive Decline and Enhances Hippocampal Synaptic Function in Aging Rats, was conducted by Latimer et al. In 2014, and they used a water maze for the evaluation measure. This study used aging rodents and attempted to model the range of human serum vitamin D levels from deficient to sufficient to test whether vitamin D could preserve or improve cognitive function with aging. For 5 to 6 months, 60 middle-aged rats were fed diets containing low, which was 100 international units per kilogram diet, a medium diet, which was 1,000 international units, or a high vitamin D diet, which was 10,000 international units. The Morris water maze tests hippocampal dependent learning and memory, and they found that rats on the high vitamin D diet significantly outperformed low and medium groups. They did this by reaching the maze goal in less time and traveled shorter distances. In addition, hippocampal gene expression microarrays identified pathways pertaining to synaptic transmission, cell communication, and G protein function as being upregulated with vitamin D. Study 5 is titled Plasma Vitamin D Levels and Cognitive Function in Aging Women, the Nurses' Health Study. It is by Bartali, DeVore, Grodstein, and Kang, and was published in 2014. It took place in several states, and I got this information from a website called About the Nurses' Health Study. It is conducted from California, Connecticut, Florida, Maryland, Massachusetts, Michigan, New Jersey, New York, Ohio, Pennsylvania, and Texas. The follow-up was 9 years, plus 1.5 to 2-year intervals. The evaluation measures were a telephone adaptation of the MMSE, as well as a telephone interview of cognitive status. The interview of cognitive status is a brief standardized test of cognitive functioning that highly correlates with the MMSE. This study included 1,185 women aged 60 to 70 years from the Nurses' Health Study. Lower plasma levels were significantly associated with worse cognitive performance on the global and category fluency scores. There was a mean difference of -0.2 between the highest quintile of vitamin D, which was on average 38.4 nanograms per milliliter, and the lowest quintile, which on average was 14.1 nanograms per milliliter for global and -1.17 for category fluency. The sixth study is another animal study. It is called Vitamin D Mitigates Age-Related Cognitive Decline through the Modulation of Pro-Inflammatory State and Decrease in Amyloid Burden. It is by Briones and Darwish in 2012, and they evaluated their findings with the Y maze and a water maze. Male rats aged 20 months, who were the aged group, and 6 months, who were the young group, were used. They were randomly assigned to either the control or vitamin D supplementation groups. The supplementation group received the active metabolite of vitamin D in the form of injection. The researchers found significantly lower levels in the aged rats when compared to the young animals. But the deficiency seen in the aged rats that received the supplementation was significantly less in comparison to the aged control group. Aged rats that received vitamin D demonstrated a decreased mean swim latency compared to the control group. Aged control animals frequently used the indirect path to reach the goal compared to all groups, while the aged vitamin D group performed better but still showed impairment in comparison to the young animals. Aged control rats showed significant impairment overall when compared to all groups. In contrast, aged rats that received vitamin D supplementation performed slightly better but still spent more time in the incorrect quadrant area and made more search errors when compared to the young animal groups. The results suggest that long-term memory recall is also affected by age, and that vitamin D supplementation diminishes this cognitive impairment. In addition, there was a 35% increase in the formation of amyloid oligomers in the hippocampus of aged control rats, and an 18% increase in supplemented rats compared to young rats. These results suggest that vitamin D was able to lessen the formation of the toxic form of the amyloid beta peptide commonly associated with aging. Study 7, 25-hydroxy vitamin D levels and cognitive performance in decline in elderly men. This study was conducted by Slinnen et al. In 2010 and took place in Birmingham, Alabama, Minneapolis, Minnesota, Monongahela Valley, Pennsylvania, Palo Alto, California, Portland, Oregon, and San Diego, California. There was a follow-up on average of 4.6 years, and the evaluation measures used were the 3MS and the TRAILS-B test. 5,995 men aged 65 or older were recruited, and of these, 1,564 participants had both cognitive testing. And then of that number, 1,376 of those men participated in a second visit on average 4.6 years later. Of men with serum vitamin D levels less than 20 nanograms per milliliter, there was an odds ratio of 1.84 for increased odds of cognitive impairment. However, when only white men were considered, there was no association between 25-hydroxy vitamin D levels and cognitive impairment by the 3MS. The study did not find an independent association between vitamin D and cognitive performance, but in the discussion they state that this may be because the participants were primarily healthy, white, elderly, community-dwelling men. They also discussed that the excluded participants who did not have cognitive testing or did not return for follow-up were older, frailer, and had lower baseline vitamin D levels and cognitive function. This next study, association between serum 25-hydroxy vitamin D and the risk of cognitive decline in older women. This is also by Slinnen and et al., but it's different, some different researchers, and was published in 2012. This one took place in Baltimore, Maryland, Minneapolis, Minnesota, Monongahela Valley, Pennsylvania, and Portland, Oregon. The follow-up was on year 6, 8, and 10, and the evaluation measures used were the 3MS and the TRAILS-B test. This study took 6,257 community-dwelling elderly women aged 65 or older and followed them for 4 years. Of these women, 7.3% were severely deficient, 32.7% were deficient, 38.7% were insufficient, and 21.4% were sufficient for 25-hydroxy vitamin D. After follow-up, 15.7% of women had cognitive decline based on their 3MS score, and 11.7% of women developed cognitive decline as defined by the change in time to complete the TRAILS-B test. In addition, women with 25-hydroxy vitamin D levels less than 10 nanograms per milliliter declined by an average 0.14 3MS points between visits compared with women with levels greater than or equal to 30 nanograms per milliliter. Study 9 is called Vitamin D Insufficiency and Cognitive Function Trajectories in Older Adults, the Rancho Bernardo Study. The author is Lawlin et al. It was published in 2017, and it was conducted in Rancho Bernardo, California. There were 4 assessments over a 12-year period, and the evaluation measures used were the MMSE, Trail Making Test B, the Animals naming test and the category fluency test. This study had a total sample size of 1,058 that were aged 50 or older. Since California has year-round sunshine, this study adjusted to season of when blood was drawn, and only 172 participants had 25-hydroxy vitamin D levels less than 30 nanograms per milliliter. For those with vitamin D insufficiency, the odds of poor cognitive function were 38% higher for the MMSE and 78% higher for Trails B, and a 2 times higher for the category fluency and long-term retrieval tests. The final study is titled State and Trait-Dependent Associations of Vitamin D with Brain Function During Aging. It is by Caitie et al. And was published in 2016. It was located in Baltimore, Maryland, and there was a follow-up time period on average of 10.4 years. The evaluation measures used were the MMSE, the California Verbal Learning Test, Trail Making Test Parts A and B, and the Clock Drawing Test. 1,207 Caucasian participants, aged 52 years on average, from the Baltimore Longitudinal Study of Aging were analyzed over this mean time period of 10.4 years. A Mendelian randomization analysis was used to examine the causal relationship between vitamin D and cognition. This study also measured the polymorphic variation in a group-specific compound gene that regulates serum 25-hydroxy vitamin D levels associated with cognition during aging. The researchers used 2 single nucleotide polymorphisms, or SNPs, that they judged appropriate for the analysis. A 1-unit increase in the group-specific compound composite SNP score was associated with a reduction in serum vitamin D levels of approximately 0.61 nanograms per milliliter. SNPs associated with lower serum vitamin D levels are associated with lower performance in executive function, visuospatial, and verbal abilities. On average, the serum 25-hydroxy vitamin D levels at baseline in this population were 32.9 nanograms per milliliter, and they saw a causal association between serum 25-hydroxy vitamin D and the clock drawing task as well as the trail making test, which suggests that low levels of vitamin D are associated with poorer cognitive performance. This next section of the presentation will be the discussion. So just to reiterate, the purpose of this systematic review was to summarize the current scientific evidence to assess the role of vitamin D on cognitive impairment to answer the question, does adequate vitamin D levels prevent cognitive impairment? So just to discuss the results a little bit, the majority of these studies showed a correlation between vitamin D and cognitive decline. Those with adequate vitamin D levels outperformed those who were insufficient or deficient. Elderly participants showed a greater cognitive decline and greater cognitive impairment than younger participants. And in the rat studies, similar results were observed, in addition to results finding the correlation between the formation of amyloid plaques and cognitive function. So here are some strengths of this systematic review. The first strength is the repeated measures of commonly used tests. I thought it was important that all of the studies included at least one similar test of cognitive function, which was the MMSE, or the 3MS. And these tests show a greater correlation between vitamin D and cognitive function because they all relate to each other. Another strength is that they're longitudinal measures. So these studies showed the effects of vitamin D in cognition over time, which there really isn't that many studies about so far. So that's another strength. A third strength is that there is both male and female participants included in the review. Some studies had both, while others had one or the other, but there was a pretty good mix of all of the sexes in this presentation. Another strength is that all of the studies were conducted in the United States. Then here are some limitations of this study. A lot of the studies had well-educated Caucasian individuals, which may have skewed the data. There is also a wide range of ages of participants throughout the studies. The youngest participant was 34, and the oldest participants were in the upper 90s, so there was a very large range. And then another limitation is that they were mixed races. And this is a limitation because African Americans are known to have lower vitamin D levels due to the additional melanin in the skin, which may also affect data. So here are some implications for the future. The systematic review shows that there's a need for further research indicating whether specific cognitive domains are especially sensitive to low 25-hydroxy vitamin D levels. Also, further comprehensive longitudinal investigations to determine the direction and nature of the correlation between vitamin D and cognitive decline. There's a need for large studies within specific geographical locations of the United States, such as the Midwest or the South, to see how much seasonality and sunlight play a role in vitamin D and how that affects cognition. There's a need for studies validating the relativeness of neurosteroids and neurogenesis to decipher the mechanistic role of vitamin D on neurogenesis. There needs to be additional studies on early stages of aging to further explore the age at which low vitamin D levels may be most etiologic, and prospective studies with repeated assessments of plasma vitamin D levels from middle to old age in populations with high variability in plasma D levels may be most informative. There is also a need for future studies on genetic variation on VDRs. This could prove insights into the underlying factors contributing to the links between vitamin D and decline in cognitive function. And finally, here are some implications for professionals. Adequate vitamin D levels suggest improved memory and cognitive function. And continued research may lead to therapeutic strategies for mitigating cognitive decline in those with low vitamin D levels. With the increasing aging population, there is an increase in the prevalence of cognitive decline. With continued research, we as nutrition professionals can recommend a vitamin D supplementation to combat this decline. It will also help us understand the mechanisms of dementia and cognitive decline and what nutrients play a role in addition to vitamin D. There's also the potential to change the vitamin D recommendation in the future to address cognitive decline, not just bone health. Thank you all so much for listening. I hope you learned a lot about vitamin D and cognitive impairment, and I am looking forward to questions and discussions about the topic. I hope you all have a great day.